All right, today we're looking at section B here, rearranging equations. And by the end of today's lesson, we want to be able to recognize the two forms of linear equations, slope y-intercept form and standard form. And we want to be able to convert back and forth between these two forms using algebra. We did a bit of this in the review, but we're going to pick up on it here. And then finally, we're going to look at a little application of standard form, which is finding the x and the y-intercepts of an equation from that standard form and using them to graph the line. So let's just jump right in here with looking at an equation of a line here. So we've got a graph of a line, y equals 3x plus 2, and we've got two numbers in this line. We've got, in this equation here, we've got the 3 and we've got the 2. And the question that I've got up there is, what is important about these two numbers? What do these numbers tell you about the line? Well, the 3 is the slope of the line, okay? And as we talked about when we were talking about slope, like if our slope here is 3 or 3 over 1, this is telling us that for our line, our slope is change in y over change in x. So our change in y has to be 3, and our change in x has to be 1. So what does this mean? It means that if you start at a particular point on your line and your change in x is 1, your change in y has to be 3. Okay? And this is like the rise and the run that we did last year in grade 9. Okay? So this first number here is our slope. Our second number over here is our y-intercept. Y-intercept, okay? Which is, if it's 2, it's our starting point right here, kind of where this line crosses the y-axis. Okay? So because this form of the equation tells you the slope and it tells you the y-intercept, we call this slope y-intercept form. Okay? Seems kind of obvious. Why is this form of the line good? Because it gives you the slope and it gives you the y-intercept, which are two valuable pieces of information about what the graph of your line looks like. Okay? Now, this is one of the forms of the equation of line that we're going to work with, slope y-intercept form. Slope y-intercept form. Okay? Also written as y equals mx plus b, where m here is the slope and b here is the y-intercept. Okay. So an example of an equation in slope y-intercept form would be y equals 3 over 5x minus 6. Here our slope m is 3 over 5. And our y-intercept would be negative 6. All right. On the right-hand side here, this is the other form that we have to deal with. This is what we call standard form. So standard form is ax plus by plus c equals 0. And all of these, like this capital A, this capital B, and this capital C, are all just numbers. And in fact, they are whole numbers. Okay. So our example here is 2x plus 3y minus 6 equals 0. A is 2, B is 3, C is negative 6. Those are all whole numbers. Okay, and I guess they call this standard form because it's kind of, it's like standardized. Everything is over on the left-hand side of the equation. Okay, now standard form doesn't give you as much useful information as slope y-intercept form does. When we look at slope y-intercept form, we can see the slope, we can see the y-intercept. When we look at standard form, it's like I don't know what the slope is. I don't know what the y-intercept is. Okay. So if they give us an equation in standard form and they want us to like graph it, or they ask us the slope or the y-intercept, we're going to want to take this and convert it into this form. Okay. And converting an equation from one form to the other just uses the algebra skills that we learned when we were solving equations or when we were rearranging equations in the review. Okay, so let's take a look at how you go from standard form to slope y-intercept form. So here's our first sort of question / example. Convert to slope y-intercept form. Okay, y equals mx plus b. They're giving this to us in standard form here. And if we want slope y-intercept form, we want y all by itself on one side of the equation. So we want to isolate y. Okay. How do we isolate y? Well, we do it the same way we isolated x when we were solving an equation. We used opposite operations to move things from one side of the equation to the other to get, x all by itself. Well, in this case, we're going to try to get y all by itself using opposite operations. That's not how you spell operations. I only need one P in there. Operations. All right, so we've got our y right here. It's part of this negative 2y. The other things that I have on the same side of the equation as that negative 2y are the 4x and the positive 8. So if I want to get rid of this 4x, I'm going to subtract 4x. If I subtract 4x from one side, I've got to subtract 4x from the other side. And if I do that, I'll have negative 2y plus 8 equals negative 4x. Okay. Then I can do the same thing with that positive 8. Right? I can subtract 8 here. I can subtract 8 here. And I'll have negative 2y equals. And then on the right, I've got negative 4x minus 8. I can't combine those two terms together, right? Because they're not like terms. One of them has an x in it. One of them has an 8 in it. So I'm still going to have both of those terms. I'll have the negative 4x minus the 8. Okay. Then my last step to get y all by itself is I've got to deal with this negative 2, which is multiplied by the y. So if I've got negative 2 times y, I'm going to divide everything by negative 2. And when I say everything, I want to make sure I divide every term on this right-hand side. Negative 2, divide by negative 2. Okay, this has got to be divide all terms. So on the left, negative 2 divided by negative 2, of course, is just going to leave me with that y. Negative 4 divided by negative 2, let's see, negative divided by negative is going to be positive. 4 divided by 2 is going to be 2, so I'll have a 2x. And then negative 8 divided by negative 4, divided by 2, sorry, is going to be positive 4. So there's my equation in slope y-intercept form. Y equals 2x plus 4. And then I could pull out the slope as 2, the y-intercept is 4. Or if I wanted to graph this, I could sub in my x values and find my y values, making that little table. Okay? So that's how we convert from slope y-intercept form to, convert to slope y-intercept form. We get y all by itself. Like solving equations, we're using opposite operations. Okay? Making sure we follow our rules for combining like terms and making sure we divide all the terms if necessary. So let's look at, we'll do a second example of this here together. Okay. We've got 3x plus 5y minus 10 equals 0. And I want to get this 5y all by itself. Okay. So what do I have to get rid of? I need to get rid of a 3x, and I have to get rid of a negative 10. And now that we know what we're doing, we could probably do those in the same step. Okay? I know I'm going to have to subtract a 3x here, subtract a 3x over here. I'm going to have to add a 10 here, which means I'm going to have to add a 10 over here. On the left-hand side, they cancel, and I'm left with 5y. On the right-hand side, I'm just going to have that negative 3x plus 10. Then to get the y, then we've got to deal with this 5 that is multiplied by the y. So I'm going to, let's do this in red. I'm going to divide by 5 on the left side. Then I've got to make sure on the right-hand side, I also divide by 5. And I've got to divide each and every one of these terms. Divide by 5. So I will be left with y on the left. For this term here, negative 3 divided by 5, I'm just going to leave that as a fraction. Negative 3 over 5x. Okay? Because if we leave our slope as a fraction, it tells us, our rise and our run. So that's fine. We're just going to leave this as a fraction. And then 10 divided by 5 gives me positive 2. Okay. All right, so that's converting from standard form to slope y-intercept form. Okay. So let's see how we go the opposite direction here. Let's say if we've got two equations that are in slope y-intercept form, and we want to convert them into standard form. Okay. Now, let's look at this one here first. We got y equals 3 over 5x minus 6. The first thing that's a problem here is the fraction. Okay, we got 3 over 5, and we don't want any fractions here in our standard form. That's like the whole point of standard form, is that there are no fractions. So our first step here is going to be to get rid of that fraction. So if this fraction has a 5 in the denominator, I'm going to multiply everything in this equation by 5. So on the left-hand side, I'm going to do 5 times y. Okay. On the right-hand side, I'm going to do 5 times 3 over 5x. Okay, minus, and I'm also going to multiply this 6 times 5. Okay, everything on the left and everything on the right has to get multiplied by that 5. Why are we doing this? Because here in this fraction, we know that this 5 and this 5 will cancel out, and that'll leave us with 3x. 5 times y will give us 5y. Negative 6 times 5 will give us negative 30. And then from here, I just want to move all of these terms over onto the left-hand side. Okay? Because I want to get the x over here, the y over here, and the number over here. So I'm going to subtract 3x. Okay? Subtract 3x. Okay? I'm going to add 30 here, and I'm going to add 30 over here. Well, that didn't fit in very well. So what am I going to have? I'm going to have negative 3x plus 5y plus 30 equals 0. Okay? Just moving all of those terms over on to the left-hand side. Okay? So get rid of the fractions, and then just move things over to the left-hand side. So let's try the second one here. I've got y equals 2x plus 3 over 4. I see a fraction here, so I want to multiply all of those terms in that equation by the denominator. I got to multiply everything by 4. So I'm going to do 4 times this y, and all of this stuff here gets multiplied by 4. Okay. So I'll have 4y here. If I multiply the 4 by the 2x, I will get 8x. If I multiply the 4 by the 3 over 4, that 4 and that 4 will cancel, and I'll just be left with the 3. Okay. Then let's get everything over to the left-hand side of the equation by subtracting 8x, subtracting 8x, subtracting 3, subtracting, oh, not add 3, subtract 3. Okay. So I'll have a negative 8x, a 4y, a minus 3, and everything on the right-hand side here, of course, cancels out to give us 0. So here's our equation in standard form. Okay. Okay, so x and y intercepts. We've got a graph here of the line y equals 1/2 x minus 2. The y-intercept is the y value where our graph crosses the y-axis. So our graph crosses the y-axis here, so our y-intercept is y equals negative 2, or the point 0, negative 2. The x-intercept is the x value where the graph crosses the x-axis. So on this graph, we cross the x-axis right here at x equals 4. So our x-intercept is the point 4, 0. Notice that for our y-axis, our y-intercept, x is equal to 0, and for our x-intercept, y is equal to 0. Okay? So we can use that piece of knowledge to find our x and our y-intercept if we have our equation in standard form. So here's our equation in standard form. 3x minus 6y minus 12 equals 0. If we want to find the x-intercept, we can set y equals to 0 in this equation and then solve for x. So if y is equal to 0, our equation becomes 3x minus 6 times 0 minus 12 equals 0. And this term, negative 6 times 0, is just, well, it's just going to be 0, right? So we have 3x minus 12 equals 0. Now this is something we can solve pretty easily. Like, we know how to do this. We subtract 12 from both sides. Sorry, we add 12 to both sides. Okay. 3x equals 12. Okay. And then we're going to divide by 3. And we get x equals 4. Okay. So our x-intercept would be x equals 4, or the point 4, 0. Okay. How do I know that the y has to be 0? Because that's what we started with way up here, y equals 0. Okay. We can do the same kind of thing to find our y-intercept. We can set x equals to 0. Okay. And our equation will become 3 times 0 minus 6y minus 12 equals 0. So 3 times 0 is just gone. Okay. Negative 6y minus 12 equals 0. And then again, we can solve this the same way. We're going to add 12 to both sides. Plus 12 plus 12. Whoops. To get negative 6y equals 12. And then we can divide by negative 6. To get y equals negative 2. So our y-intercept is y equals negative 2, or the point 0, negative 2. okay, because we set x equals to 0 and our y is -2. So usually what they want you to do with this is they want you to use these intercepts to graph your equation, okay? So they'll give you the equation, they'll ask you to find the intercepts, and then use them to graph. Okay? So let's try one of those, okay? We are going to, whoops, here we go. Find the x and y intercepts and graph the equation. All right, so for our x-intercept, y is equal to 0, okay? And if y is equal to 0 in our equation, this term here, this -2y, is just gone. So we can just write down 4x. It's like we can just cover up that -2y, plus 16 is 0. Okay? We know how to solve this. We're going to subtract 16 from both sides, and then we're going to divide by 4. Okay? So our x-intercept is at x equals -4, which is going to be 1, 2, 3, 4. Whoops. 1, 2, 3, 4, which is going to be right here, -4. For our y-intercept, okay, we're going to set x equals to 0. Okay, so it's like this 4x term right here is just gone. We'll have -2y plus 16 equals 0. Oops. Let's move this up a little bit. We'll subtract 16 from both sides. -16, divide by -2, y equals 8. So our y-intercept is going to be way up here at 1, 2, 3, 4, 5, 6, 7, 8. And then we just connect those 2 points. Oh, that's no good. I want to move this line here. Oh, the line won't move. All right, we'll just have to draw this line by hand. All right, and we just connect these 2 things with a nice straight line. And that's our graph. This is our 8. Okay. So we can find the intercepts and then use those intercepts to give ourselves 2 points to graph our line.